Hello, today we're going to start section 5.1, two variable coordinates in equations. The objectives are to identify points, quadrants, axes, and the origin of the Cartesian plane, explain the relationship between the solution set of an equation in two variables, a plot in 2D, and a set of coordinate pairs, determine if an ordered pair is a solution to an equation in two variables, and plot the solution to a two-variable linear equation in the Cartesian plane. Part 1. Cartesian coordinates. The Cartesian plane is the 2D rectangular coordinate system which is built from the horizontal x-axis and the vertical y-axis. These axes intersect at a unique point called the origin. These axes intersect at a right angle, and these axes cut the plane into 4 quadrants. So this picture off to the right, the horizontal axis, that's our x-axis. The vertical axis is our y-axis. Here's the origin. And then the quadrants, there's 4 of them. You start in the top right, that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4, ending in the bottom right. We can plot ordered pairs AB as points on the Cartesian plane. The origin has the unique start coordinates of 0, 0. To plot any other pair, x, y, start at the origin. Move left or right the length indicated by the A or x coordinate. Move down or up the length indicated by the B or Y coordinate. Plot and label each point on the coordinate plane to the right. A, 2, 3. So we go right 2, up 3. B, negative 2, 3. So to the left 2, up 3. C, negative 1, negative 1. So to the left 1, down 1. And D, 3, negative 1. Go to the right 3, down 1. Label each quadrant and determine what type of point, for example, plus negative, live in each quadrant. So for A, that was positive, positive. That's in the first quadrant. So the first quadrant contains the positive, positive. B was in the second quadrant. All those will be negative, positive. C, which was in the third quadrant, those are all negative, negative. And D was in the fourth quadrant, and those are positive, negative. Part 2, graphs as solutions to equations. So far, we have only looked at linear equations, such as 3x minus 2 equals 7, which involve only one variable. Similar to a one-variable inequality, we can plot the solution of a one-variable linear equation on a number line. For example, if we solve 3x minus 2 equals 7, we add 2, 3x equals 9. Divide by 3, we get x equals 3. So when we plot that on the number line, because x equals 3 is the only solution, you only get a singular point at 3. Today we're going to start looking at linear equations such as 3x plus 2y equals 1, which involve two variables. Instead of a number line, we'll plot the solution sets to these on a Cartesian plane. As such, a solution to a two-variable equation is an ordered pair, such as x comma y equals 1 comma negative 1, which indicates substituting both 1 for x and negative 1 for y to make the equation hold true. Note that unlike in one variable case, a linear equation in two variables has many solutions. Example 2. Determine if the following ordered pairs are solutions of 3x minus y equals 1. So like said above, for 2, 5 to be a solution, that means when we substitute 2 in for x and 5 in for y, does that make this true? Well, that's 6 minus 5, which is 1. So yes, this is true. So this is a solution. Do the same thing for negative 2, negative 7. So 3 times negative 2 minus negative 7. Does that equal 1? 3 times negative 2 is negative 6. Minus a negative is plus 7. Negative 6 plus 7 is 1. 1 does equal 1, so this is a solution. And then finally, for negative 16, negative 5, 3 times negative 16 minus negative 5, does that equal 1? 3 times negative 16 is negative 48, minus a negative 5 is plus 5. Negative 48 plus 5 is negative 43. That does not equal 1, so this is not a solution. Example 3. Determine if the following ordered pairs are solutions of 4x squared plus 9y squared equals 100. So 4 times 4 squared plus 9 times negative 2 squared, does that equal 100? Well, 4 squared is 16, so we get 4 times 16 plus 9 times negative 2 squared is 4. 4 times 16 is 64. 9 times 4 is 36. 64 plus 36 is 100. So this one checks out. So this is a solution. 0, 5. 4 times 0 squared plus 9 times 5 squared, does that equal 100? Well, that 0 squared is 0. 5 squared is 25. 4 times 0 is 0. 9 times 25 is 225. 0 plus 225 is 225, which does not equal 100. So this is not a solution. Then finally, check to see if negative 3 comma 8/3 is a solution. So 4 times negative 3 squared plus 9 times 8 over 3 squared, does that equal 100? 3 squared is 9. So is negative 3 squared. 8/3 squared, well, that's 64 over 9. 4 times 9 is 36. 9 times 64 over 9, the 9's cancel out, so we get 64. 36 plus 64 is 100. So this does work out. So negative 3 8/3 is a solution. The solution set of an equation in two variables is the collection of all ordered pairs that make the equation true. The graph of the equation consists of the plot of all of these ordered pair solutions and can therefore be thought of as a visual representation of the solution set. As the name suggests, the graph of any two-variable linear equation forms a line. Sketch the graph of y equals 3x minus 1 by generating a table of values, plotting points, and then filling in the gaps to make a complete line. So, when you're asked to make a table of values, it's always a good idea to do a t-table. So x, y, and you pick 3 to 5x values. Let's go ahead and pick 5. So I'm going to go ahead and pick -2, -1, 0, 1, and 2. It's always a good idea to pick some negative, always pick 0, and pick some positive. So then y is 3 times -2 minus 1, which is -6 minus 1, which is -7. 3 times -1 minus 1 equals -3 minus 1, which is -4. 3 times 0 minus 1 equals 0 minus 1, which is -1. 3 times 1 minus 1 is 3 minus 1, which is 2. And then 3 times 2 minus 1 is 6 minus 1, which is 5. I want you to notice how the y values change with respect to how the x values are changing. And now let's plot these points. -2, -7. So go to the left 2, down 7. Well, that one's off my graph, so I'm going to skip that one for now. -1 to -4, so over 1, down 4. 0, -1, so don't go left or right, but then go down 1. 1, 2, go to the right 1, up 2, and then 2, 5. Then you try to draw a straight line going through these, because that represents all the other solutions that we did not find. So notice, even though I couldn't plot the -2, -7, the other 4 points were sufficient. Then last but not least, example 5, use the graph of x squared plus y squared equals 25 below to find a few ordered pairs in this solution set. So I'm looking for points on this graph that will give me solutions to that equation. Now the first one I see is right here. So that means 5, 0 is a solution to the above equation. We also have 0, 5, -5, 0, and 0, -5. I'm going to find one more, but then I want you guys to find 2 or 3 on your own. For example, I see this point over here, so -4, 3, is also a solution to the equation x squared plus y squared equals 25. We'll talk more about the details of two-variable linear equations in the next section. And that is it for section 5.1.